Hello, here's another AQA A-level physics question from the thermal physics topic. If you want to answer the question yourself, pause the video now. If you've got the answer C, well done. So a sample P of an ideal gas contains 1 mole at an absolute temperature T. A second sample Q of an ideal gas contains 2/3 of a mole at an absolute temperature 2T. The total molecular kinetic energy of P is E. What is the total molecular kinetic energy of Q? So the first thing I'm going to do is I'm going to look and see how much the kinetic energy changes for one molecule when we double the temperature. We can use the following equation from your data book, and it says that the energy of a gas molecule is equal to 1/2 times the mass times the root mean square speed squared, and that's equal to 3/2 multiplied by the Boltzmann constant and the temperature. So this here is the kinetic energy. Not surprising really, 1/2 mass times velocity squared, but it's the kinetic energy of one gas molecule. So we can see that the kinetic energy is directly proportional to the temperature. So it says that the temperature of Q is 2 times the temperature of P. So the kinetic energy of a molecule in Q must be 2 times the energy of a molecule in sample P. But they've also changed the number of particles. So the number of moles is directly proportional to the number of particles. So if I multiply this number for the energy for each particle by the change in the number of moles, I'll get the total change in energy of the gas. So the total change in energy of Q is going to be 2 times the energy of P. Remember, these are just for the single particles, multiplied by the change in the number of particles, and that gives me 4/3 EP. I hope this was useful. I hope you'll watch more. Press that subscribe button please and watch more of these in the series. Thank you.